Bonjour and welcome back to another episode of T.E.D Mini. I'm Sir René and together we'll be learning about technology, engineering and design. In today's episode we'll be learning about levers and linkages. Linkages are systems that are generally made up of simple bars which are connected together at the end with some sort of pivot. The joint can be as simple as a pin joint, a sliding joint, or even a ball and socket joint. To reduce wear and tear on these joints and to reduce friction, which is the main form of energy loss, lubrication and ball bearings are used when possible. Linkages are normally used to transfer movement from one place to the other, change the direction of movement, to change the amount of movement or its force. At their core, they are simple levers with metal bars connected to their ends to make the transfer of movement or force easier. The amount of type or movement a linkage will perform will depend on the amount of bars, joints, as well as fixed points. Let's look at three forms of linkages. The first is the bell crank linkage, made up of mainly three parts with one fixed point and two free moving joints. It allows changes in the direction of movement and is incredibly useful. Its name originated from the shape of its middle section. However, nowadays, it is more common to find the middle section cut in an L shape as it reduces the material needs and thus the weight and cost. The next form of linkage is the reverse motion linkage. As the name suggests, it is designed to invert the direction of rotation with its Z shape. It also has just one fixed point and two free moving joints, just like the bell crank. However, the change in shape of the middle section makes all the difference. The last form of linkage is the parallel motion linkage. As the name suggests, it is designed to transfer the input force in such a way that the output force is parallel to it. This time, the linkage has two fixed points, which create the distinctive parallel motion. This form of linkage is mostly used to create a mechanical advantage or a change in velocity using the following equations. Taking an input force to be of 30 newtons and an output force to be of 60 newtons, we can divide our output force of 60 newtons by the input force of 30 newtons to find that the mechanical advantage is of 2. As the distance of the second lever is half that of the first, divide these distances to work out a velocity ratio of 2, meaning that the load has also been moved at double the speed of the effort. And that will be all for today's episode of T.E.D Mini. I hope you have enjoyed this mini episode, and if you have any comments or suggestions on how I can improve these videos, please leave a kind comment down below. Remember to like and subscribe, and if you have been, thank you for watching.